Hi folks, so welcome to another video tutorial. So this question is from the exam papers. It's 2019 ordinary level section A question 3. So the question asks, the image below shows a cutter which is part of a paper punch down here. The cutter appears as a parabola in elevation. The drawing shows the outline elevation of the cutter. A portion of the left hand side of the parabola here, which is inscribed in the rectangle ABCD, is shown. V is the vertex of the parabola, so V is the top point of the actual parabola. So we're asked to locate the remaining points on the left hand side here, locate the points on the right hand side, and then draw the complete parabola. So we're going to deal with the left hand side here first, and basically what we need to do is we need to figure out how many equal divisions we have between B and V. Now you can see here they've already started by putting in a few divisions here. So if I were to divide the section from here to here up just in half, we're going to have 4 divisions, but they're not going to be 4 equal divisions. So I'm going to make an assumption that it's going to be 5 equal divisions. So what I'm going to do is I'm going to start working on the question, and I'm going to have a line coming out from V at no set angle but relatively shallow. And what I need to do now is I want to have 5 equal marks coming off that line. So with my compass, now what's important here is that you keep your compass relatively small. So if I set it to that distance there, for example, I'm not going to fit 5 divisions into that. So I'm going to keep it relatively small, and I'm going to start marking them off. So that's 1 division there, 2, 3, 4, and 5. Now, those divisions don't have to be within this line here. They could extend up there like so. So what I need to do now is join that last division back to V, and ultimately what I need to do is all these points here, I need to bring them back down to the line BV. That's going to be parallel to that first line there. So I'm going to use a sliding set squares method, and I'm going to offer up 1 set square to that line there. I'm going to bring in a second set square here, and I'm going to use that as a sliding set squares to bring the rest of the lines down parallel. Now you might need to readjust it to get it right. Now I suppose that's a good test to see how accurate I am. You can see these 2 lines that have come down match pretty much bang on what the 2 purple lines are there. Okay, so now what I can do is these last 2 lines here, I can bring them straight down. Again, they should be relatively light there. So now I need to repeat this process on the line AB, and because we had 5 divisions here, we're going to divide the line AB into 5 equal divisions as well. So again, so from point B, I'm going to draw a line out, and as before with my compass, I'm going to set my compass so we can easily get 5 divisions in. So we have a bit more space here now. So I'm going to use 5 divisions here again, 4 and 5. And what I can do here is this point here, I can join it back to that last point there like so. And as before, I'm going to use my sliding set squares. So I'm going to offer up 1 set square, and I'm going to have a second set square in here. Might bring it up closer so you can see it. So offer up 1 set square, bring in a second set square here. I'm going to use that to slide it up then. So I'm going to bring these remaining points down. And that's the last one done. Now what I need to do is join all of these points back up to V. Now I'll start with this one here. And again, this is a good test of our accuracy, and depending on how accurate you are, these two lines should go through the existing points there, like so. And you can see here that's worked out perfectly for me. So we need to get the last two remaining points. So you can see here, this first line here, when I crossed that first line, that gave us a point there. This second line here, when I crossed that second line, that gave us a point here. This third line, where it crosses the third line here, that's going to give me one more point there as well. And this fourth line here, where it crosses the fourth line there, that's going to give me another point there as well. So basically, we've been asked to locate the remaining points on the left hand side, and that's what I've done there now. Okay. The next part of that question then is to locate the points on the right hand side. So if we wanted, we could repeat this entire process and bring it over to the right hand side, but that's an awful lot of work. So what we can do is just bring these points, these lines over, I should say, okay? Bring these lines over, and I'm going to bring them all the way over to the edge there. Just for the moment, we won't use the full length of it. But basically what we can do now is the distance from the center line to the point, I can take that measurement and bring it out to the other side. And for that, I can use my compass. So I'm going to set my compass from the center line to the first point there. And I can mark that dot there. The second one, I can take that measurement there and apply it to the second side as well. The third dot, and repeat that process as well. And the fourth one is quite small, and I can repeat that there as well. Okay, so now I have my 4 points. I'll just highlight them a little bit better there. So that's part B done. So part C then, it says, is to draw the actual parabola or complete it. So basically now I can just draw the actual parabola then. Now with a parabola, it should be, as best as possible, it always should be a curve. Okay, you should never really have any type of straight lines there. So I'm going to repeat that here on this side as well. Now if you can, go lightly first, and then you can actually line it in as best you can then. So I'm relatively happy with that. So I'm going to go over it a little bit heavier. And ultimately, that is the question complete. The final thing I will show you though before we finish up is to show the examiner how you got these points. What you could do is show them that this distance from here to here is the same from here to here. So what I'm going to say is this line here is equal to that line there, and you can see what I mean there is the line from here to here is equal from there to there, and I'm using a bit of color, and I'm going to use different colors for this line here. So I'm going to say that's equal to that there, for example. That's in green, and the final one maybe from there to there and from there to there are equal as well, and I'll just use blue for that.